Hi. For my concurrency project, I created a simulation of a chord-style distributed hash table, and in this video I'm going to quickly go over how my code works. So each chord node is represented by a single thread. The first thing it does is call this join network function, and so first it selects a random ID between 0 and 255 because we're using an 8-bit hash. It creates a queue for other nodes to message it at, and it selects a random node to ask some initial questions to so that it can join the network. The first node is just going to set its predecessor and all of its fingers on its finger table to point at itself, since there aren't any other nodes to point to. Otherwise, it's going to select a random node and ask that one to find the predecessor of its ID. Once it's got that, it's going to ask its predecessor for its successor. And then it's going to run through its finger table and update all of its fingers to point at its successor. These are going to get updated once the node is live, but for now they're just initialized to point at the successor. This flag is used so that once it enters its main message waiting loop, it knows to update its fingers. So once it's joined, it needs to let the nodes next to it know that it exists. So it sends a message here in the stabilize function to each of the nodes next to it and tells them to update their successors and predecessors to point at it. So in this run function, this while loop here is the main body of the code. It's mostly just a check to see if it needs to update its fingers. This is just a quick message buffer here that's not really used, but it might be used if I were to continue working on this. And then this just is a big set of if statements that checks what kind of message it's been passed and processes that message accordingly. So for get requests, set requests, and finger updates, it does the exact same flow of messages. And so we'll walk through how that works. So this node receives a get request. It's going to call its get function, which is down here. So the first thing it does is it hashes the file name sent in that message and checks to see if it belongs to this node. If it does, it just gets that value and prints it to screen, and that's the end of that story. But more likely, it belongs to some other node. So first thing it needs to do is find the predecessor of that node. So it's going to look up on its closest preceding finger function to find the closest node behind it, and it's going to send this find predecessor function to it. That message will get passed along until it finally reaches the node that it's supposed to. It invokes where is it? It invokes this remote find predecessor function, which basically does the same check that initial get did. Checks to see if it's the predecessor. If it is, it sends its ID back to the original requester. If not, it forwards the message across. So once this message has been passed back to the original sender, in our main loop here, it's going to trigger this find predecessor result branch, and it's going to call this find successor function. This is just going to send a message directly to the predecessor and ask it what its successor is. It's going to send a message back with that information and trigger this find successor result branch. And at this point, it needs to know what it needs to do with this information. So every message contains all the information necessary for completing that query. So once a thread has sent a message out, it has no recollection of that message request. It just does this so that it doesn't need to maintain state of anything. The message contains everything that query needs moving forward, and every node will be able to independently figure it out. So there's a second field on the message called mode, and this is to determine, like, okay, this node got this successor result. Now I need to know if I'm using this as a get, a set, or a finger update. If it's a finger update, then the successor in this find successor result is the node that one of my fingers should point to. So I'll call this update finger function and update my finger table. If it's a get or a set, it basically does the same thing and forwards a get request or set request message directly to the node that is responsible for that data. And so that's going to invoke the same function that originally started everything, except this, the receiver this time should definitely pass this initial if condition where it checks to see if it's the one responsible for that data, and it'll set it, or if we're setting, this is a nearly identical function down here, we set that data locally right here, and then print to screen. And that's basically how my project works. Thanks for watching.